Hello again, this is Jordan Goldmeier, and we're going to talk about development principles. And these are the principles that are going to guide us as we develop dashboards and data visualizations in Excel. And in fact, they're very important. This is the subject that is often skipped over by so many Excel courses that there really isn't a way to develop. It's all just a canvas, go at it, or the other way, which is do things this specific way, and that's what you need to do. So here we're going to try to hone in and say, here are some of our objectives and our goals, because here's the reality. Rote memorization of the material I'm presenting here is not necessarily going to help you. We have to think differently, and if we're going to think differently, we have to have goals in mind to guide us. And in the way that we're shaping our thinking, we can actually see solutions much more easily, and we can make better work. So let's get started. There's 3 development principles I'm going to advance to you, and they're ones you've actually probably heard before, so none of this is typically new for anyone in this field. So the first is transparency. In a second, we'll talk about what that means, but here we can just think of it as being able to see through what we've done. So if we've built a model in Excel or a dashboard or something like that, it should be transparent. We should be able to figure out and unpack it. If someone asks us a question, we should be able to think about it. So developmental memory, that's really important. The work that we put in Excel needs to sort of live there. It needs to be remembered there so that someone can come back to it, they can see what has been done or they have an idea. And finally, efficacy. This surrounds confidence, right? Our work has to create confidence, and we need to create confidence in it. So let's talk about transparency and dig deeper into what that means. So I like to think about this in terms of a question. Can you easily ask and answer questions about your own work without having to unpack all of it? So when you go to unpack and to figure out, someone said, why is this data point this thing? Does it feel like you're just opening up something modular, which it should, just to check? Or does it feel like you're pulling the whole dashboard of your car out to get to the one little light that doesn't work? Now, if it's the latter, then you're not developing well. Your work is not transparent. So transparency doesn't necessarily refer to your ability to figure out what's going on. It refers to the universal ability to unpack it and for other people to even know the questions that they ask, because they can sort of get what's going on. The second thing is that errors should not be thrown away. So there's this terrible VBA practice. I don't know if some of you do VBA. You've heard of this. You can put this line in your code that says on error, go to next, which tells VBA if there's an error, ignore it, right? So this is not a good practice. Sometimes, unfortunately, it's something you have to do when you code in VBA, but often it's what people do when they don't understand the error. Just say ignore it, and sometimes there are important errors that you want to see when you've built something big, and it just glides right through them. You don't even know that there's a problem. So your work, and I should also compare this to the big BI vendors. They have work. It's not transparent. You don't know the code behind it. You have to call someone up to figure out what's going on. The work that we build here, we need to see those errors immediately. They need to break our work, because when they break, we stop. It's kind of like Kaizen, the Japanese method of manufacturing. So in America, when we would say never let the line stop. In Japan, if there is an issue, you want that line to stop. So we're going to develop in that vein. When things are problems, they should break, even if it's in front of someone. We don't want to give them wrong answers, because that's far worse. And finally, as a follow-through or a follow-up to that idea of easily seeing errors, you need to be able to track them down. And in the dynamic that I'm going to present in a later module, you're going to be able to do this, because we successively will divide visualization and the data and the work that we do on it such that whenever there's an error, you should be able to track it down and figure out where it is, and others will too. That second objective, developmental memory, that refers to being able to pick it up later and figuring out what's going on. So we need to develop in a way that makes our work remember, that there's some sort of memory in our work of what we've done. Now, this isn't very hard. If we have formulas, for instance, that correctly match what we're trying to achieve, in that way, we are able to put a memory of what we're trying to do. And we're going to talk about that more in the next module and talk about it a little bit at the end of this section. But there's a way to develop sort of semantically that it's an expression of what the underlying problem is. And in that way, it's actually very easy to remember what we've done. Now, contrast this with these giant VBA models that exist out there where there's just thousands of lines of code and modules. It's very hard to figure out what's been done, and you have to find that person who did it, and you got to bug them. What we want to do is develop so that our work, that there's some sort of memory in it. It's not just for someone else. It's also for us, because 6 months later, we are going to look at that work, and we're going to say, what the heck did we do? Now, if we do it well, we will remember very easily, or at least more easily, than these other methods of development. And finally, formulas are not just readable. They're connected to what we're trying to accomplish, and that makes them understandable and more easily explained, more easily understood within the context of everything we're trying to complete within our work. And finally, efficacy. This is one that's often forgotten about. Does our work inspire confidence? Now, what does that mean? It means that it can do what we say it can do. So if we are not capturing errors in our work, so if we are doing that on-error go-to-next method, what's happening is that those errors are just being funneled through the dashboard or funneled through the model or through our Excel application, and we're not capturing what's going on, so we can't actually say that it does what we want it to do. And the same could be said when we build formulas in Excel and we just leave these div 0 errors on our spreadsheet. What do these mean? What can they be traced to? Is everything working towards the goal of monitoring a system or creating a report that someone can answer a question better? Does our work support that, or have we left a lot of these artifacts of things that we were trying out in the back end parts of the spreadsheet? So let's develop with the goal in mind that our output is the most important things, and what we're doing is to support that output. So our work needs to inspire confidence, and the way it does that is by being quick and fast and actually challenging much of the conventions in Excel, because as we've talked about, Excel itself is not inspiring much confidence in the world, but it doesn't have to be that way. So let's go back to that one problem that we asked about. Now here, there's not a real business case, so this is just a sample problem. But when we have a business case, it's actually a lot easier, and we'll talk about that in the next module, that if we can relate it back to something we can understand, it can actually be easier to create formulas we understand. But let's just think about this problem again. So take a moment and look at this problem again. Now let's go take a look at our solution. So we have 3 solutions here. We talked about the nested if, we talked about the Boolean logic, and for a second we talked about the simplification. So I'm going to just think through these out loud, because this is how I think about which would be the best. So in the first case, we have this nested if. So the underlying problem was really just a list of items. It wasn't conditional, right? So when I think of nested ifs, I think of something conditional in the sense that we look at this last test here. So this is, if it doesn't satisfy this first condition, we're going to go to this next nested if, and if it doesn't satisfy that first condition, it finally goes to a third condition, which through that we've sort of covered all the possibilities. And this is the common way to solve these types of problems. To me, this type of setup does not accurately reflect the underlying problem, or what I often say in my other talks is that it doesn't naturally extend from the underlying problem. What we're dealing with, that previous problem setup, it's not really conditional. We don't actually go to this final nested condition because we didn't satisfy the other ones. That's just sort of a dynamic that we're forced into through the nested ifs. So perhaps when we use nested ifs, we should think more flowchart-like, right? If the problem could be mapped in a flowchart, maybe that's where we should think about it. And we'll talk about that more later. And this next one, Boolean logic. Now, there's something to this that I actually rather like, because it appears to go in the order in which the problem was described. So it's slightly off, but we could actually fix it to be on. So in this case, I'm kind of jumping to the second condition. What I'm saying is A1 greater than 50. And then, so I'm not really testing if it's less than, but I could have. I could have tested if all of them were less than, so I could have had a series of 4 Boolean quantities instead of adding this plus 1. I did this because if it's less than 50, it's always going to be multiplied by 1. But I didn't have to do it this way. I could have just done one quantity as A1 less than 50. Is it less than 100? Is it less than 150? And so forth. So I could have set the problem up to more easily align with how the question was stated. And I actually really like that, because to me, we had our problem statement, and this is kind of a natural expression of that. So then finally, we have the simplification one. Now, this one has kind of a nice feeling to it because it's a lot smaller, right? So it uses fewer characters. Now, also, we've taken advantage of this mathematical property of dividing things, and we have integer division that actually helps. So this is, in a certain sense, we've simplified it, and if we could take bigger problems in Excel, which we can, and we can condense them into things like this, our spreadsheets will actually run faster if we can find these tricks. So just to review, the nested if I don't particularly like, but it's a very easy solution if you want to just do something quickly. The Boolean logic I like because it matches the underlying problem. The simplification problem I like because there's a shortcut in it that would be faster processing. But what's most important to me is being able to understand later what I've done. So for me, the choice is the Boolean logic. But here I'm not going to propose that there's a right answer to you. I'm not. I will say that we use if way too much and that there's too many nested ifs out in the world. So I'll say that. But I'm not going to tell you that there's a right or wrong answer. The point here is that we need to think about it. So this is a continuous process. It's not something that there's a right or wrong. How do I make this formula as simple and as small as possible? Don't think like that. Rather, think in terms of goals. Is the formula I'm writing, does it allow for transparency? The nested ifs, I do not believe allows for very good transparency. Does the formula have some sort of developmental memory in it? Well, the Boolean logic one actually kind of does because it mirrors the underlying problem statement. Finally, can we inspire efficacy with it? I think that the Boolean logic one we can because of the developmental memory and because it's not a crammed nested if that we don't quite understand. The simplified version probably actually has the worst, in my opinion, of developmental memory because it's a trick. We're not quite sure what's going on. So that one has benefits, but it's also one we probably should exercise some caution over. So take those 3 development goals and maybe throw them up on a wall or put them up on a bulletin board and try to think through these problems within their context. How do we optimize them in the work that we do? So I just kind of wanted to show you this, why I picked the one that I picked, and I'll just let you look at it for a second. So you can see it's almost a one-to-one match, and that's what I really, really, really like about it. But again, think about these things in the context of it and know why. So that's why I have this slide to you. If you're going to pick something, you should know why and be able to explain it. And to me, that is really what efficacy is all about. So efficacy is part development in our work, but it's also very much about us and the way we interact with our work.